Let's look at another example where we find the intersection point between two lines. We saw in the first problem how to solve a system of equations, and we saw that it was useful to have one equation in slope-intercept form. But what if neither are in slope-intercept form? In this example, let's find the solution to the linear system of equations 2x minus 3y equals 7 and 2x minus 2y equals 6. We can do this by putting one of our lines in slope-intercept form. More generally, we need to solve one of our equations for one of our variables, either x or y. For now, let's solve the second equation for x. If you would like to see the steps done out, click the purple link to the left. By adding 2y and dividing by 2 on both sides, we can solve the bottom equation for x equals y plus 3. It's worth pointing out that we could have chosen any of our four options, solving the first equation for x, solving the first equation for y, solving the second equation for x, or solving the second equation for y. Any of these would have worked, but we needed to pick one. Now, using x equals y plus 3, we can substitute it into our first equation as we did in the last problem. Doing this, we get the equation 2 times x, which is y plus 3 from the blue line, minus 3y equals 7. We can solve this equation now that it is an equation of just one variable, y. If you would like to see the steps done out, click the purple link to the left. Solving this, we find that y equals negative 1. Now that we know y is negative 1, we can solve for x in any of our equations. The easiest equation we can use is the one that's already solved for x. X equals y plus 3. Plugging in y equals negative 1 in this equation gives that x equals negative 1 plus 3, which is 2. So we can conclude that 2, negative 1 is the solution to the system. If we would like to visualize this, we can graph the red and blue lines and see that they meet at the point 2, negative 1.